Welcome everyone to the training for the Tree Health Monitoring Program. My name is Kim Ernst-Pitcher and I'm the Habitat and Agriculture Program Specialist at Prairie Rivers Network. I'm an ecologist by training and am PRN's lead for the monitoring program. Assisting us today is Marty Kemper, retired biologist with IDNR. Over the past several years, he and many others have been observing, documenting, and closely following the geographic pattern of injuries to trees and plants that are symptomatic of off-target herbicide exposure. This monitoring program was developed from published resources and conversations with professional biologists and foresters and is supplemented by the experience of this group of observers from around the state. All of the monitoring forms, instructions, and guidelines can be found on the Prairie Rivers Network website under Resources and then again Tree Monitoring. Also on our website is the Illinois Department of Agriculture's Pesticide Incident Complaint Form. This is their method of evaluating and tracking pesticide complaints. If you have suspected injuries to trees and plants on your property, we encourage you to fill out this form and send it to IDOA. They use this information to make regulatory decisions, so the more information they have, the better equipped they should be to make such decisions. Today you will learn how to use the monitoring form to record symptoms of possible off-target herbicide exposure to trees and other broadleaf plants. The training will start off with a brief introduction to some of the information gathered so far. Then Marty will walk you through how to use the form, identify symptoms, and how to select and monitor locations. I'll then wrap up the end of the webinar with a very brief tour of the online reporting system. Please keep in mind that this webinar is rather long. The total length is about 1 hour, 40 minutes. We encourage you to take a break during the webinar, or perhaps to even view it in a couple of segments. Without further delay, we're going to jump right into today's training. I'm going to be quiet for the next few moments while I take you on a short tour of a portion of the data that has been collected over the past 2 years. What all of these photos have in common is that they all show tree foliage with injuries that are consistent with herbicide damage. In most cases, off-target herbicide exposure is a likely cause. Now, these symptoms have been observed with sufficient regularity over the past few years to prompt concern. They've also prompted us to ask several questions, such as, what is the frequency and timing? How geographically widespread are they? How many species are affected? How severe are the effects? Is there a trend in occurrences? And are there unobserved injuries occurring? We do know that oaks appear to be especially affected and are of special concern. This is because they're often a dominant species, they are keystone species, they provide hard mast and important food resources for wildlife. They're Lepidoptera hosts, and they're economically valuable as well. Protecting oak is protecting the future productivity and biodiversity of Illinois forests. And it's estimated that today, forest cover in Illinois is less than 12% of the state's surface area, but contains 70% of the state's native biota. Now, this is a map showing counties with observed symptoms. Please keep in mind that this is data from the reports of only 6 part-time volunteers over the last 2 years. And there's 2 key points here. About half the counties have 1 or 2 reported observations, and there's a need to increase our knowledge of where and when symptoms do and do not occur. And as you can see, most of Illinois has been unmonitored. This really highlights that there's a need for science in 2019, and we plan to do this by expanding the monitoring. And we hope that this expanded monitoring will lead to causation analysis and effects analysis. But right now, we're just going to focus on the monitoring. Now, how are we going to do this? Well, volunteers are one of our best resources. In order to really get an idea of what's happening around the state, we need your help. There are some things that you will need in order to be a volunteer for this program. We request that you take the monitoring paper copy of the monitoring forms out with you in the field, as well as a notebook, pen or pencil, and a clipboard. Binoculars will be very helpful when you're trying to look further up in the canopy than your eyes allow, as well as photo equipment. We do request that you take photo documentation of any of the symptoms that you're monitoring. We also require a GPS coordinate for the location of your monitoring. So you can do this with your smartphone or at home using Google Earth Pro. And of course, we'll be out in the field, so please use insect repellent and dress appropriately. There are a few skills that are helpful. The main one is your ability to identify trees. You don't have to be an expert though. There are many field guides that are very helpful. And if you have a friend or a buddy that is really good at identifying trees, we encourage you to take them along. The team approach is certainly encouraged. There are about 30 common species of trees that you'll encounter out in the field. You don't have to know them all, and you certainly do not have to know the distinctions between the difficult species. So what if your ID is difficult? We're fine with you reporting tree species simply as hickory. So if you know it's a hickory, but you're not sure exactly what type of hickory it is, you can just record hickory. The same with maples, elms, ashes, catalpas. You do not have to know the specific species. ID may be particularly difficult with some of the oaks. In this case, if you know that it's a white oak, it has rounded lobes without bristle tips, then you can simply report that as white oak group. The same goes for the red oaks. If you know it's a red oak and it has pointed lobes with bristle tips, then you can just report that as red oak group if you do not know the species. Now this training will give you some of the skills to identify symptoms of potential off-target herbicide exposure to broadleaf plants. If you need some further help, there's many resources, some of which Marty will mention further down in the program. And there's also a photographic tutorial that we have on the Prairie Rivers Network website. And this shows numerous species showing many of the symptoms that we're looking for in this monitoring program. So feel free to refer to that either while you're out in the field using your smartphone or at home. Now I'm going to turn it over to Marty, and he's going to go through the form and go through identifying symptoms and how to select a site. Thank you very much.
Thank you, Kim. And I too would like to welcome everyone to today's webinar. And thank you for taking an interest in this project. Much appreciated. Our goal today is to build a foundation for planning and executing on-the-ground field monitoring that is the heart of this project. Specifically, we'll try to familiarize ourselves with the report form that is used for data collection. We'll introduce the set of symptoms associated with herbicide injury that are the focus of our project. And finally, we'll provide some guidelines on things to consider and also some pitfalls to avoid that will help make the data that you collect as useful as possible and help save some valuable time and effort in the field as well. Kim will come back later to discuss reporting that data. Along the way, we'll have approximately 3 exercises and a little digital field trip that will help you, we hope, build and sharpen your observation skills towards this project. So let's get started. So what will volunteers do? Well, we're going to make and record observations. We'll talk about that. We'll talk about selecting sample sites. We'll talk about determining a sample schedule. And then we'll also have some information about submitting reports at the end. So with regard to making observations, we're going to be making visual observations of the presence or absence of a specific set of mostly leaf abnormalities, which we'll call symptoms here. You'll be recording this data on paper forms, and then eventually have an opportunity to transfer that information to an electronic form for permanent records. You'll also be asked to make a photographic record of what you're observing. One of the questions that I'm often asked is just how prevalent are these symptoms out in nature? And of course, as Kim pointed out earlier, that's a question that we're trying to find an answer to. But we already have, I think, perhaps reason to believe that we have some answer to the question, and that is it's likely that they're a little more common than we normally recognize. And I want to give you a reason, perhaps, for why that might be the case. And that is, in my experience, and the experience of several others, these symptoms are easily overlooked. And I want to give you a specific example of what I'm talking about. This is a site that I monitored in 2017 on May 1st. It's in rural Washington County, and it's a post oak stand. And what I found on May 1st were trees that exhibited moderate to severe symptoms that we'll be talking about later, the kind that we're looking for. So these symptoms were found throughout virtually all of the trees that you're looking at in this stand, because these are all post oaks. This is just almost a pure post oak stand. I came back to this site on August 22nd to do a follow-up monitoring on it. When I pulled up along the road, I looked at this stand from the road, and this is the picture on August 22nd. I thought to myself, this looks absolutely normal. I even thought to myself, perhaps I didn't even remember correctly where I had been, because the trees looked normal. But I'd like to show you what the reality is here. And I point out that this picture was taken right on the edge of the road, about 60 feet from the edge of these trees, which then the trees are about 60 feet tall. So let's look a little bit closer. We're going to pick 3 trees here. We'll just call them tree 1, tree 2, and tree 3. And these are actually the places where the following photographs are going to come from. And we're going to look at these trees closer. This is the foliage on tree 1 in this photograph. This is the foliage, and this was throughout the trees on tree 2. And this was what the foliage looked like on tree 3. My point is that looking at even fairly close distance at trees that I knew had injury did not help me when I was standing further away to really decide whether or not there was any foliage injury on them or not. It can be very difficult to detect. So that's certainly a reason that perhaps these injuries are overlooked a little bit in the landscape. I'll just mention a couple of other reasons that perhaps they're more prevalent than we commonly acknowledge. And that could be a lack of knowledge associated with whether, even if you see injured foliage, whether or not it's normal or not. Some people really don't know if what they're looking at is normal or not. In some cases, people may recognize that these are abnormal leaves, but not really figure out that there's any potential harm to the plant. And so don't pass along that information. And finally, even when people do know they're looking at potentially harmful symptoms, they really have no idea where to report this suspected injury. So all of these things together make me think that perhaps these symptoms are more prevalent out there than we really think about. The tool we're going to be using for doing this monitoring is our tree and plant injury report form. And here's a version, the paper version of this form. And it's the basic tool. We're going to look at this in some detail. And this will bring up all the topics, basically, that we need to talk about with regard to the monitoring program. In addition to the form, there is a document, form instructions, and it explains in more detail what each section, how to fill out each section of the form. And there's also another document called Volunteer Guidelines, which also covers various aspects of the planning and executing the monitoring program. And I direct your attention to those three documents, the report form, the form instructions, and the volunteer guidelines. Copies of those, all three, can be found on the Prairie Rivers Network website. And I just want to show you what that looks like. Here's their homepage on Prairie Rivers. If you go to resources and tap on that, you'll get a drop-down menu. And if you go to tree monitoring, you will be taken to a page that provides all three documents and some other information as well. We are going to take a look at the form specifically now, and we're going to first do a quick overview. The form is 2 pages, front and back. So one sheet has a front and a back, page 1 and page 2. So we'll look here at page 1 initially. And basically, this form can be divided into 3 different sections. The first section is on observer and location information. We'll talk about the details of that later. The second section gives you an opportunity to record whether or not symptoms are present or whether they're absent. Okay, and this would be either simply check boxes. That's all. You just check yes if it's present, leave it blank if it's not. And finally, there's a section with 3 questions, rather simple questions on to describe the site in more detail. We call that the site ecology section. Now, the second page is much simpler. The second page of the form on the sheet is simply a place to record symptoms observed on more species. And to give you a closer look at this, this is what that symptoms section looks like on page 1. You'll notice there are opportunities to record data for 3 species. If we bring in page 2, you'll see that there's an opportunity to record the same data, same information for 3 more species. So one sheet can be used to record data for up to 6 species. In addition, on the second page, we have a very small note area for some additional site ecology, and we'll talk about that in a minute. And then finally, down at the bottom is just a quick reference section that tells us, gives us a quick reference on remembering what these various symptoms are. So that's the second page. Okay, so now we're going to look at this in a little bit more detail. First of all, with regard to the observer and location information. First, the observer data, okay? And this is very simple. We'll go through this very quickly. First name and last name is required on the form. Just simple things you might expect. Contact information includes address, city, and zip. We assume you're from Illinois, so there's no place for state on there. In addition, we'd like a phone number and an email address. And then finally, on the observer data, if you have a witness, that is someone who's helping you with the monitoring, or witnesses, it could be more than one person, there's a place to record that name or names on there. And these are just people who can vouch for the date and the time and the place that you've been in the observations that you made. That's the observer data, basically. One other thing, there is a place for the date at the top, of course. That's very important information. And then finally, if you're just using one sheet, this would be sheet 1 of 1. You can use additional sheets if you want to do more than 6 species at a site, in which case you would have a second sheet. Okay. Next, the location data. What are we asking there? Well, first of all, we just ask you to give each site a name. We call it the site ID. And if it's a very large site and you're doing a small portion of it, you may want to designate a subunit to the site as well. In addition, we ask you to record the county that the site is located in. Next is a question about, is the visit planned or not? And let me explain what we mean by that. Basically, and there are 2 check boxes. It's either yes or no, okay? And you check the yes box if the data collection at the site was planned before knowledge of whether injury symptoms were or were not present. You check no otherwise. And let me give you an example. If you plan to go to a site well in advance, you don't know whether or not there are symptoms there or not,
that you would check, yes, it's a planned visit. But suppose, for example, that you were at a site, perhaps doing an exotic species control day, work day or something, and you observe injury at a site and you think to yourself, oh, well, I think I should report this, okay? Well, in that case, you really don't have a planned visit because you've made a decision to record the data after you already know whether or not symptoms are present. Similarly, you might be at a location, maybe another exotic species control work day, and you notice you're in a forested area and you notice that there are no symptoms present. And you decide the same thing. Well, I think I should record that, and you should if you have an opportunity as well. So in either case, those would be no or not unplanned visits. Okay, hopefully that explains that idea. We do ask you to number the visits at a site serially. The first visit, of course, is visit number 1. There is some value in going back, and we'll talk about this, to do repetitive monitoring at particular sites, in which case, we just number these visits serially, number 2. If you do serial visits, you should always make sure that you're using the same site ID number, and if you use a sub-ID name, and the same subunit name on subsequent visits as you used on the first visit. Of course, subsequent visits would always have a new date. Okay, just 2 more items, I think, with regard to location data. We are asking for GPS data to help locate these monitoring sites. We're asking for that data in a format called decimal degrees. And here's some examples. These are just examples of decimal degree entries in GPS units for latitude and longitude. Many GPS units, Google Earth Pro, provide GPS data, latitude and longitude, in degrees, minutes, and seconds. I just want to let you know that different ways to deal with that in terms of converting to decimal degrees is to go into your GPS unit and change the settings. You can take the degree, or you can take the degrees, minutes, and second data and go online and find a converter. They're free. It's pretty easy to find those online. And you can convert your degrees, minutes, and seconds data to decimal degrees. You can also do that in Google Earth Pro. There's a way to do that there as well. And finally, we'd like to know where the GPS point that you're taking, is just one per site, is in relation to the total sample area. So one way to do that might be to take the GPS point in the middle of the site. One might be to take it at a specific corner, but we'd like to know where that is. So for example, if you were at a site and you took that GPS point at the southwest corner of the area, just write that down. Took the point at the southwest corner of the area. Okay, well, that's the observer and location data. We'd like to look at the symptom information right now and how we would go about filling this data in. Okay, so what we're looking for here are, we will be identifying herbicide injury related symptoms. These are the symptoms that we're looking for. And our symptoms come from a variety of sources. The descriptions are basically an integration of symptoms that are described from a variety of sources. One of the prime sources that we used was the Plant Clinic report for oak problems. And that has a specific section on herbicide injury. And in that section are described the various symptoms that one might expect with herbicide injury. Okay. A second and really good source of information, you may want to consult these and just read about this on your own. A second good source is Diseases of Trees in the Great Plains. It's a U.S. Forest Service publication. It's very recent, November 2016 it was released. It's from the Rocky Mountain Research Station of the U.S. Forest Service. And there's a whole chapter on herbicide damage to trees and shrubs. In fact, there are 2 chapters that relate to herbicide damage that you may observe in trees and woody plants. Okay, well, what are these symptoms and how does one report them? Basically, we need to understand that we have 2 different kinds or groups of symptoms that we're going to be discussing, 2 general types. The first we call indicative symptoms, and at least, and these are just a definition, at least one indicative symptom must be present to indicate the potential for herbicide injury. And if we cannot find any of these indicative symptoms present in the foliage that we're examining, if they're absent, then there is no indication of herbicide-related injury. Okay, so that's an indicative symptom. There's a second set of associated symptoms we call additional symptoms. What we can say about these is these are symptoms that can be associated with herbicide injury, or they may be typically associated with other causes of injury as well. Now, in other words, these are not indicative of herbicide injury, but they're often found in association with foliage that does have indicative symptoms. We only record additional symptoms if indicative symptoms are also present. And hopefully that will make sense as we go through these symptoms. Okay, so on the farm, we have these organized in the following way. This particular section of the farm that we've just outlined here is the place where we list the symptoms, both indicative and additional, and where we would record in the field whether or not these are present or not. So the indicative symptoms are bolded on the farm, and they're listed first. We'll talk about the fact that they're divided. Well, we'll just mention that they're divided into two groups in a moment. And then the additional symptoms are listed second on the form. I probably will emphasize this too many times, but I will just note that the form itself mentions that at least one indicative symptom bolded under symptoms must be present, that is checked. Otherwise, the injury level is 0, meaning there's no injury indicated. And in case you couldn't read that because it's too small, I've got that same statement here in a little bit bolder letters. Okay, now these indicative symptoms that we're talking about are divided into sort of two groups. Most of them are associated with leaves, 7 of them exactly, and 2 of them are associated with shoots. Now, the list may look kind of imposing and kind of long, but I'd like to at least provide this information, and that is that for the most part, just 2 of these symptoms will cover probably a majority of the kinds of foliage damage that you encounter in the field. All of these symptoms are present in the field, and you will encounter them at times, but curled and cupped leaves and twisted, deformed, or stunted leaves are clearly the most common things that we've been encountering over the past few years. And once you learn these, you will be in a really good position to commonly identify these symptoms. Okay, so indicative symptoms, we're going to take a look at these one by one so that we kind of become familiar with what we're talking about. The first is curled or cupped leaves. And here we see this in hickory. At the top, we have curled and cupped hickory leaves that are fairly modestly curled and cupped. And then, as you can see, a more severe type of injury at the bottom on this particular slide. Here's the same symptom in white oak. This is fairly young white oak. It's just emerging. The leaves are probably about 2/3 grown, and you can already see significantly curled and cupped leaves in this particular situation. Here are the same kind of symptoms on elm and on maple, to give you a feeling of what it looks like on those species. And poison ivy is a species that often shows these symptoms, and this is a sort of a moderate level of curling and cupping on poison ivy. And finally, this slide illustrates an interesting point, I think, and that is that while everything that we've looked at so far shows curling or cupping downward, which is what we see on the red bud on the left side here, that curling and cupping in some instances can occur upward as well, and you can see that on the red bud on the right-hand slide here. The next symptom I'd like to talk about is called twisted, deformed, and or stunted. And this is kind of an amalgam of several kinds of deformations of the leaf that often occur together. The first thing I wanted to do here was show you a normal post oak leaf and show you that some small level of curvature and asymmetry in a leaf is perfectly normal. And so I want to point out that the post oak leaf you're looking at is normal, and I'd like for you to contrast that with one that is showing twisted, deformed, and or stunted leaves, which is the next slide. Now here we have this is post oak again. I know it's a little hard to recognize, but here we see a whole group of sort of related deformations in the leaf that collectively we call twisted, deformed, and or stunted. And I'm going to go through these one by one just to show you what we're talking about. First, the leaf blade is twisted, meaning that if you want to look at it, the central vein is undulating. It may go left, it may go right, it may go left and right, in sort of an S curve or something like that. That's not unusual. Secondly, you can see that the leaves are often irregularly proportioned from the base to the end. The base may be too big in relation to the end of the leaf, what we call proximal to distal ends, or the other way around. It may be very small at the base end compared to normal and very expanded at the end of the leaf. That's kind of common. There's a loss of bilateral symmetry, meaning that the blade tissue on one side doesn't match the blade tissues on the other side, which would be normal in most of our leaves. And that relates to the next item, which is they can be irregularly lobed, meaning compared to normal, the lobes are too short and wide, or they're maybe too long and narrow. Both of those things occur. Finally, there's often, not finally, there's one other thing, irregular surface, meaning that there's sort of a puckering of the surface. I think you can see that in these leaves, that the blade surface is not smooth, but it's puckered. And one really important part of this twisted, deformed, and or stunted is the stunted part of this. Often you see these leaves being stunted, meaning they're much smaller than average. Okay. One thing I want to point out is that there's, with regard to this symptom, is there's perhaps not all of these, but there's almost always more than one of these things going on at the same time with these leaves. Okay. I just wanted to point out that this same symptom can occur not only in woody plants, but in some of our herbaceous plants. This is a prairie plant, compass plant, and you can see certainly the twisting of the leaf here and the central vein being a sort of S shape. And you can see some irregularities in the lobing. These lobes are way too long and narrow and so forth. So this is an example of twisted, deformed, and or stunted in the silphiums, the compass plant. In fact, that whole group of silphiums, compass plant, prairie dock, rosinweed, and cup plant, tend to be species that in prairie situations may show these indicative symptoms on foliage. Another one of our symptoms is called irregular margins, and this one's really simple. And here you see it on flowering dogwood. What we have here are the leaves having unusually scalloped or wavy edges. Normally in flowering dogwood, these edges should be smooth. And what we see here is what we call an irregular margin, kind of a scalloped edge. Flowering dogwood seems to be a species that is especially prone to this. Redbud is another species that's especially prone to this particular characteristic. The other part of the irregular margin, not only just the wavy or scalloped edge, is what we see here in wild grape, and that is oftentimes we see the blade tissue not catching up with the veins in development. So what you can see is sort of the veins sticking out as decided points on the edge of what would otherwise pretty much be a smoother leaf edge. So this is a part of that irregular margin kind of symptom as well. Another symptom has a pretty fancy name. It's called Epinasty, but really all it means is it relates to what's happened to the leaf petioles, which of course are the little stalks that hold the leaf blade. And Epinasty is where the leaf petioles twist so that the leaf surface, the upper leaf surface, either is pointed sideways or maybe even upside down. It often happens in ginkgo. We see this quite a bit in ginkgo and in other species as well. And so this is Epinasty, or sideways and upside down leaves. If the bottom of the leaf is colored differently than the top of the leaf, this is usually pretty easy to see from a distance because it gives the whole tree kind of a checkered coloration pattern. Another thing I want to point out right here is that rarely do we see these symptoms totally in isolation. So we see Epinasty here in this ginkgo, but if you look at this and you're familiar with a ginkgo at all, you will notice that we have stunted leaves here. And we also have leaves that are deformed as well. So, these symptoms, it's very hard to find photos, for example, that just illustrate a single symptom because oftentimes they are linked together. But this is a good example of Epinasty. Another of the indicative symptoms is called strapping, or the leaves are strapped. And that refers to simply an unusual or unnatural elongation of the leaf in relation to its width. And you can see that here in bur oak. You have to, of course, be familiar with what these species look like to be able to identify this. But bur oak seems to be a species that is particularly susceptible to being strapped and demonstrating this particular symptom. Okay, another one is what we call veins bleached and or parallel, and or venal bleaching. And we'll talk about the parallel veins in just a moment. But here you see this illustrated in two species, walnut and hickory, walnut on the right, hickory on the left. Notice that we'll look at the walnut first, and it's probably easiest to see. The veins are quite yellowed. They're chlorotic. They've lost their chlorophyll. The blade tissue, on the other hand, between the principal veins is still green. This is what we mean by venal bleaching. And you can see that as well in the hickory on the left. It does appear that hickories sometimes are a little more prone to this than perhaps some of the other species. Now, what about the parallel part of this? Veins bleached or parallel. Well, you can kind of see this in redbud right here. These are redbud leaves, if you can't identify them. We'll look at the one on the right first. Notice that the main veins here are virtually parallel, almost like what you'd expect to see, say, in monocots like iris or orchid, something like that. And that has to do mostly with how the leaf has developed. So you get these parallel venation. You can also see that on the left slide here, the veins are relatively parallel in this redbud leaf. You can also see that there's also some venal bleaching going on as well in the one on the left. So veins bleached and or parallel. Here's another characteristic symptomatic of herbicide injury, and that is tatters. You can see it on white oak. At this level of expression of this symptom, it's pretty easy to identify. It's really refers to a loss of blade tissue, a significant, sometimes almost total loss of blade tissue between the main veins. However, there are some less severe expressions of this symptom, and I'm going to show you two examples here on this next slide. If you look on the right first, the previous slide was white oak. This is pin oak. These are all from the same yard, by the way. Pin oak in the same yard as the white oak we just looked at. Pin oak on the right, I hope you can see the same characteristic development of loss of leaf tissue in the pin oak on the right. However, it's only happened on a portion of the leaf. And then if we look at the leaf on the left, which was just a couple of feet from the tree, from the leaf on the right, you will see a very modest expression of tatters. Now, one thing I want to say about tatters is it can be, especially from a distance, confused perhaps with some insect damage, especially when you get to the point where you're just seeing holes in the leaves like on the left. Now, one of the ways you can tell it from insect damage is that if you look at those holes that are there, you will see, and you may have to do this with a magnifier, that the edges of those holes were grown in, that is, they formed in the growth process. There's no indication of any insect damage or feeding on them. However, if you saw this at only a distance, let's say you're looking up in a tree, you see these holes, I honestly do not believe that you can differentiate tatters at this stage, at this level, from insect damage. And so we really wouldn't report it unless you're able to really closely examine the leaf, or you're seeing damage that is closer to what we're seeing on the right side of the screen. Unless one can verify that this is not insect damage, ignore the situation where you just have a few holes until you at least become more experienced. Now, those are the leaf symptoms. We have two symptoms that are indicative that are related to shoots. The first is shoots that are elongated, coiled, or bent. And I apologize, it's not the world's best photo, but it's the best I had available to illustrate this for a woody plant. And that is, this is blackjack oak, and I hope that you can see that the shoot has become extremely elongated, and in this case, of course, it's bent downward. As with a lot of other symptoms, it's really not elongated, coil, and bent here is not just by itself. If you look at these leaves, you can see that they're slightly deformed as well. I'm going to show you the same shoot later in the summer. A couple of months later, this is the same shoot. You can still see the bending, but it might be hard to actually at this point identify that this was sort of an unnatural growth. So this is one symptom that probably is most easily identified early in the growing season. Here's that same symptom in some herbaceous plants. This is white wild indigo in a prairie, and I hope that you can, and these are the flowering, the inflorescences. And if you're familiar with this plant, you can see that those shoots are rather unnaturally elongated. The nodes between the various points of flower attachment are greatly increased. And if you look at the one in the middle, you'll see that the shoot is coiled as well. Now, the very last indicative symptom related to shoots is what we call growth suppressed and deformed. And unlike the last symptom where the shoot has been unnaturally elongated, in this case, the shoot is unnaturally compressed. That is, it hasn't lengthened properly. And what this creates is a very bunched appearance on the leaves. And so they're just kind of all jammed together. Now, I've never seen this situation without the leaves themselves also being deformed. And so what you can see here is what we have, highly deformed leaves along with this growth suppression. So growth suppressed and deformed in a shoot. There's an example, and this is an example on oak, black oak. I want to show you another species that seems to be extremely prone to show this particular kind of symptom, and it's box elder. And if you look at the foliage in this slide, you'll see that the bottom foliage closer to the trunk on the tree looks normal, but the shoot itself, you can see, is not developing properly. The shoot is being growth suppressed. The leaves are being deformed. Okay, so there's a quick look at our indicative symptoms. I want to give you some recording guidance really quickly now that are sort of tips on how to go about thinking about these symptoms when you're in the field. One of the things I want to point out is that something we need to all keep in mind is that occasional irregularities are normal. That is, occasional irregularities in leaf development or shoot development are normal. We're going to look at an example of that in just a moment. A second thing I want to point out is that we're really only looking for prominent symptoms when we're out in the field. We don't have to spend a lot of time, for example, if you're looking at a tree, trying to look through all the foliage to find just one or two examples of each symptom. We're just looking for the ones that really pop out at you when you look at the tree and within a moment or two, within a minute or two. And then finally, we're going to talk about later, I'll give you an example of what it means to stay within your expertise. There's another, some guidance that we want to follow. Okay, so with regard to this idea that some irregularities are normal, I want to show you an illustration from the Trees in Missouri by Don Furs. And in it, he illustrates pin oak leaves. And he also shows that, we have what is an abnormally, obviously unusual leaf here. And what he's trying to say, I think, in this illustration is that while most of the leaves look like those on the left here, occasionally in nature, you're going to see something that looks like this leaf on the right. So point being, an occasional abnormal leaf abnormally developed leaf is a normal situation. When you see the kind of symptoms that we're looking for, you're not going to have to search for an occasional leaf here or there that has this kind of abnormality. They're going to be the predominant manifestation of the foliage. Okay, so we've got a couple of exercises here for you to kind of maybe exercise your brain a little bit about maybe sharpening your skills a little bit on identifying symptoms. And so here's one of those exercises. We're going to look at 3 pin oak trees and photos from 3 pin oak trees. And I want to let you know that all these photos were taken on the same day at the same location in a municipal park in South Central Illinois in this case. And we're going to try to see if we can spot the prominent indicative symptoms on these leaves. So here's the first photo. Okay, I'm going to let you look at it for just a moment and see what you can see here. And then I'm going to show you what I see as prominent symptom or symptoms in each photo. Okay, so here's what I saw in this photo. I see leaves that have a puckered surface. That is, the leaf blade surface is is not smooth. And also I see pin oak leaves that have unusual lobing. In particular, they seem to have suppressed lobes. The lobes aren't nearly as long and narrow as they normally would be. Both of those fit into this twisted, deformed, and or stunted category. If I look at these leaves, some of them do look small as well, I have to admit. Now, what I don't see here, and what I would look for normally, because one of the first things I look for are cupped and curled leaves. And there may be some slight indication of that here, but I'm really looking hard and I don't see it. And so in the back of my mind, I'm thinking, yeah, there's a little bit of cupping and curling, but would I actually record that? I'm not sure at this point, probably not. Okay, here's another tree, same location, same date, pin oak again. And what do we see here? Well, what I'm seeing here is leaf blades on the pin oak, especially these larger ones that you can see more prominently in the front, where the end of the blade looks rather normal for pin oak, but if you go further back on the leaf at the base end, all the blade tissue is virtually missing. There's just very little in comparison to what there normally would be. So we have a deformed leaf here. As well, when I look at the, a little further back in the foliage here, I begin to see lots of little leaves that show some level of twisting as well. So I think what I'm looking at here again is twisted, deformed, and or stunted. And once again, I tend to expect to see cupping and curling as one of the first things, and I really don't see that here. So I'm not sure at this point that we really have any cupping or curling. I want to show you a third tree now at this location. Same day, same location. Pin oak again. And I think all of a sudden the thing that jumps out at you here is the fact that we're looking at rather heavily cupped and curled leaves. If I look at this a little bit longer, I can see that maybe the leaves are a little smallish. They're probably stunted to some extent. The lobe, unless we could see these a lot closer and maybe have them in our hand, whether or not the lobing is unusual or not, you might not know. I can see that there is some unusual lobing here. So in this case, we have cupped or curled, yes, and twisted, deformed, and or stunted, well, maybe yes or no, but because we already had it on two other leaves, I think we've confirmed the fact that all of those are present. So if we were filling out our form, we write here in the common name section, we say we looked at 3, and how we fill this out is we would say with regard to symptoms, and we're just looking at indicative symptoms now, we have curled and cupped, and we have twisted, deformed, and or stunted. And that would be the report for pin oak at this site, except for 2 items, which we'll talk about in just a moment. Okay, so now I want to give you some information about additional symptoms. And we're going to look at these one by one. Again, these are symptoms that in and of themselves are not indicative of herbicide-related injury, but we'd like to record if they're present when indicative symptoms are also present. Now, the first one is called chlorosis, and that simply refers to a loss of chlorophyll in the leaf, which typically gives the leaf kind of a yellowed look. It may be gray or whitish as well. Here we see it on hackberry. If you'll notice, these leaves are rather heavily cupped or curled. Okay, and so in this case, we would want to include chlorosis as another symptom recorded on the form. If we saw these leaves without any indicative symptoms, we wouldn't be recording chlorosis for hackberry or any other symptom as well. This slide also points out, I think, something that we talked about earlier, and that is staying within your expertise. And if you don't know what the normal coloration of hackberry is, then you probably are not going to be able, you might have a question about whether or not this is normal, but if you're not confident that this is not the normal coloration, then don't record it. That's true for any of the symptoms we're talking about. If you're looking at a particular species and you see something that you think may be abnormal, but you're just not confident about it, just pass it by. Just pass it by. Okay, here's the next additional symptom. It's called necrosis. And we see that here on swamp white oak. This is a area of dead tissue on the leaf. And this can be the whole leaf. It can be a part of the leaf. And it often is at the edge of the leaf. And if necrosis is occurring on the leaf, it sort of proceeds usually from the end to the base or from the outside of the leaf inward. Necrosis, a dead tissue on the leaf. Pretty easy to see. This, the third and last additional symptom for leaves is called second growth. And what we mean by second growth is that there's often in oaks especially, we'll use them as an example, there's an initial flush of leaves. And if that flush is damaged, okay, as you can see in this photo, the initial leaf flush has a high level of damage. Often oaks will try to put out some additional new leaves. And we can see those here as relatively normal leaves. This is a white oak, I do believe, a black oak, I'm sorry. So the leaves are relatively normal. So this is second growth. If this second growth is present, and we see that on a tree and foliage that has an indicative symptom like cupping and curling we see here, we would like to record it. Here's another example of second growth. This is on white oak. And again, you can see the initial foliage here is showing injury or damage. And you can also see that the tree is trying to put on some additional new growth that perhaps might compensate for that. Second growth. Now, we're moving on to some symptoms of additional symptoms that are related to the whole trees. The first we call Epicormic Sprouting. It's kind of a fancy name, and I really don't have a simpler name for it. It refers to the sort of very dense growth of short twigs and branches that does occur on the main branches or even on the trunk of a tree. This usually occurs when the tree is pretty highly stressed and may be experiencing some real dieback of the branches and so forth. Epicormic branching. Typically you see this in oaks, can be seen in other species. We've seen it in ash and hickory in some cases, but oaks seem to be particularly prone to this condition. As for all additional symptoms, remember, we're recording only if indicative symptoms are also present. If you're looking at this slide, we really can't see at this from looking at this slide whether or not any indicative symptoms are present or not. We're just not looking closely enough at the foliage. So in this case, we really don't know whether or not it should be recorded until we look closer at the leaves. The final two additional symptoms deal with whole trees also. The first is called dieback. Dieback is simply where branches have died. And then we have death, is where the tree has died. These are symptoms, okay? Now, we only record dieback and death if the branch leafed out and then the leaves died during the current growing season, or the whole tree leafed out and then died or is dying in the current growing season. If you see branches that have no leaves, or you see a tree that has no leaves on it, that is not examples of death or dieback as we're defining them here for additional symptoms. Once again, you would have to know that indicative symptoms were present for, in the first place, to record death or dieback as well. So you probably would have had to been out to look at the tree on, let's say the tree on the right, earlier in the season to see that it was green, and that it also had some indicative symptoms on it before you would record death. Okay, those are just some examples. There are lots more examples of all the symptoms that we just talked about, and they're illustrated on the Prairie Rivers Network website. And that's located on the same page as the forms, the guideline, the volunteer guidelines, and the form instructions. And there's also a section on what normal leaves look like for many, many species of trees as well. Okay, so now let's do a little exercise to identify indicative and additional symptoms at the same time. Okay, and we're going to look at one redbud tree from an urban yard. Okay, and this is the tree, and here's a picture of the foliage we'd like to look at. And I'm going to ask you to think about how many prominent symptoms do you see here? And I'll give you a little clue. I identified a total of 4 symptoms, 3 indicative and 1 additional here that are prominent. I'll give you just a moment to look at this, think about it a little bit. And then I'll indicate the ones that I was seeing in this slide. Saw leaf cupping in this slide, saw irregular margins, and I saw stunting of leaves in this. And to give you some examples, just quick examples of where those are on the slide, hopefully this will illustrate those. Now, in terms of additional symptoms, I also saw chlorosis in these. That is a yellowing of some of the leaves, a loss of chlorophyll. Okay, so those are the symptoms that we saw. So if we were recording those, in this case, we had one red bud in an urban yard. We'd say we had, the approximate number observed was 1. And we had leaves cupped or curled. We had irregular margins. We had twisted or deformed leaves. And down in the additional symptoms, we had chlorotic leaves as well, chlorotic foliage. Okay, we just have 2 summary measures of the observed injury left to talk about. And they're in this part of the form. We skipped over those before. We'd like to talk about those now. The first is the percent of the foliage affected on the entire tree. We want to rate those in terms of percentage categories of just 4 simple categories here: 1 to 25, 25 to 50, 50 to 70, 50 to 75, and 75 to 100%. In other words, it's 1/4, half, 3/4, or most of the foliage affected by the symptoms we're looking at. So going back and looking at this slide again, if I told you that the entire tree looked like this, which it did in this case, in this particular urban yard, what percentage, how would we rate the percentage of the foliage affected? And that would be right in this area right here on the form. In this case, we should be rating that at 76 to 100% to describe the percent of foliage affected. And then the very last item here is the average and range of injury of the symptoms that we're observing on the foliage. And we're going to talk about how we rate injury level here. If injury is present, we want to estimate the average level and the range, meaning the lowest level of injury that we observe to the highest level of foliage injury that we observe on the subject species. We're rating this on a scale of 0 to 10, and this is a subjective scale. All right, so 0 to 10. 0 meaning the least, and 10 being the highest level of damage. So on the form, we're going to enter the average and the range. As I mentioned, this measure is relatively subjective. Do the best you can. There are numerous examples of rated foliage for this injury level on the Prairie Rivers website, and again on the same page that you go to for the forms, instructions, and volunteer guidelines. Just to put some words to some of these numbers, use the following injury scale. 0 is no injury observed. Now what that means is you are not seeing any indicative symptoms. It doesn't mean that all the foliage you're looking at may look uninjured. You may have insect damage, you may have disease damage, you may have a lot of the additional symptoms. But if you're not seeing indicative symptoms, we're rating the injury as 0, none observed. Okay, and then we have these other categories: slight, light, moderate, severe, and extreme, and numbers that accompany those. 1 and 2 is slight, 3 and 4 light, 5 and 6 moderate, 7 and 8 severe, 9 and 10 extreme. We would like you to reserve 10 for trees which leafed out and died or appeared to be dying. So 10 is sort of the most extreme example where we have a total plant death occurring. So everything in between is sort of a scale of 1 to 9. Okay, so here we have an exercise to rate the average and range of injury. And we're going to look at red bud again. And this time we're going to look at 3 trees from the same urban yard that we had the red bud from before. But now, again, instead of looking at 1, we're going to be looking at 3 trees. Now, I know you haven't had any experience at this, but I'm just going to give you some examples of how I have rated these injury levels. And these are, I think, relatively consistent with other observers that I've been working with. Okay, so here's this red bud again. How would we rate the level of injury on a scale of 0 to 10? Well, it's not 0 because we're seeing indicative symptoms. It's not 10 because obviously all the foliage isn't dead. We can't look at the whole tree, but we know the whole tree is not dead. So it's somewhere in between. Now, when I first look at this, I just look at this in sort of ranges, and I'm looking at this and I'm saying, I think this is about a 7 or 8 injury level. And my pick here was a level 7 injury. Okay, so that's how I rated this particular redbud. Now here's a second redbud. Now this is a hypothetical example because these trees actually came from a couple of different locations, but we'll assume they're all from the same monitoring site. Okay, when I look at this, give you a chance to look at it and think about what you might rate it on a scale of 0 to 10, actually 1 to 9 in a sense. And what I would say here is the thing that came to mind with me is this is probably a 4 or 5. I'm going to probably go a little bit higher on this one and say I'd call this an injury level 5. And then finally, here's our third tree. That is rain on these leaves, not something else. But how would I rate the injury level on these? And my thought here, when I looked at these leaves initially, were this is probably a 2 or a 3. And if I had to make a decision, I'm probably going to downgrade this one to maybe a 2. So in the end, I would have rated this about a level 2 injury. You know, your mileage may vary, obviously. It's a subjective rating. So what have we got for scores here? Well, we rated these 3 trees at injury levels 2, 5, and 7. So we have a range of low from 2 to high of 7. And if you work out the average here, it's 4.67. Now, this isn't rocket science. We're not going to use decimal points. So just round that to the average that makes sense to you, the average that makes sense to you. And in this case, given that we're just looking at 3 trees, I think the average that made sense to me was to rate the whole 3 trees at an average of 5. So if we go back and look at our form, this is the data that we had for perhaps for the 3 trees. And we're looking specifically now at the average and range of injury. And for the average, we have a 5. The range of injury, we'd fill that in at 2 to 7. And that would represent a complete record for a redbud at this particular site. Okay. I do want to talk to you a little bit about selecting sample sites. We're going to go through this pretty quickly. There is one section that we will have to spend a little more time with that talks a little bit about one of those pitfalls that we talked about that we want to avoid. First of all, with regard to location, you know, we're dealing with the state of Illinois. We really don't have any a smaller size sample area than that. Anywhere in the state is fine. And the same with land use types. We really don't have limitations. You know, we can have conservation areas, natural areas, municipal parks, cemeteries, orchards, urban and rural land. You know, you can just keep going on with that list. One of the things we need to mention is that if you happen to be working on private land, you clearly need permission to access that land. And I would mention also that if you're working on public land, that there's usually a public land manager. It certainly doesn't hurt to make contact with that individual or individuals and just tell them what you're doing. I think they may be interested in learning about what it is that you're doing. On private land, though, we certainly want to have permissions to do our monitoring. Now, we do have an emphasis on trees, but I'm going to point out that areas with other plants of any kind are also within the purview of this monitoring program. So we certainly are thinking about, in terms of wooded areas, you know, forests, woodlands, and savannas. We certainly are not ruling out and would like to look at prairies and other grasslands as well for these symptoms. They certainly will show up there. I've given you a couple of examples already of injured plants. And then finally, we're also looking at cultural areas like plantations or yards or gardens. You can also report on these kinds of areas as well. Now, this is the situation I wanted to talk to you about that is a little tricky that we need to think about for a moment. And that is landscape context. Now, there's no limitation on the landscape context in which we can monitor, but there's a big but here, and that's be aware or perhaps beware of edge habitats where plants can take up soil-applied herbicides. And I'll give you an example here in just a moment, but what we're talking about is that when woody vegetation occurs along the edge of open areas, especially croplands, what we probably, we see the trees, but what we don't see are the root systems that extend out into adjoining cropland. This is fairly typical for this to happen. And where this happens, we know that soil-applied herbicides on the cropland could be taken up by those roots. So symptoms that we see in the trees could occur due to root uptake of the soil-applied herbicides, is the point. Now, let's take an aerial view of this same kind of situation, okay? And what we're really talking about is along the edge of a wooded area, there's a potential, it's adjoining cropland, there's a potential root absorption zone, we can call it, okay? And by the way, this is a real sample site, and it's a state nature preserve, okay? So this is a real sample site, and or monitoring site, and a real landscape situation, okay? So the question is, how do we avoid confounding symptoms related to root zone uptake when we do our monitoring? And the answer is knowing how far into this edge, into the forest, this edge effect occurs or extends, and then treating those differently. So the question is, how far into our monitoring area does this edge effect occur? And I will say that that distance is really hard to know, but it's probably safe to estimate at about equal to the height of the tallest plants. So if the trees along the edge of our field here are 60 feet tall, then we can probably say that maybe trees up to 60 feet from the edge could be potentially affected. That may be a little far, but that's a pretty safe estimate. So ways to deal with this potential root zone effects when we're monitoring, okay? And one way to do this is to monitor to avoid the edge. And so what we're looking at is this. We just monitor the site, but we avoid those edge areas. If you do that, you want to make a note, probably, of the fact that that's the way you proceeded in the monitoring effort. That, you know, I monitored this site, but I did not monitor, none of my results are from the edge area that are adjoining cropland. Now, a second way to do this is it's pretty similar. Monitor all, the entire site, okay? The area that is edge and the area it's not. But again, make a note if the edge is different in terms of the symptoms that you see. Make a note, indicate that. Either way is acceptable, two ways to deal with this. This whole situation brings us to a rule that's a good one to follow, and that is avoid samples that only include areas potentially affected. Avoid samples that only include areas potentially affected by root uptake of soil-applied herbicides, unless you can absolutely verify that there is no root exposure. So what are we talking about here? If your sample site is just a woodland border or just a fence row that's adjacent cropland, that's probably not a very good place to do this sampling. Secondly, and there's some other situations that are very similar, areas with total weed treatment. For example, this is the second picture I just showed you, the tree with the area around it where there's total weed treatment is from a municipal park. It's not unusual in these areas for there to be what they call total weed treatment or total vegetation management around trees for mowing purposes so that mowers don't have to get too close, and that can be with herbicides. Now, if you could verify that this was just a great job of mulching, that's fine. You know, we're not dealing with potential root zone issues. But if you can't, avoid that kind of situation. And finally, another area where this kind of situation may occur, root zone uptake, is from lawns and turf that are treated for broadleaf weeds. If you're in a urban residential or even rural residential situation, and you see lawns that are perfect, beautiful grass, you probably can figure that there's a lot of broadleaf weed control going on, and the woody plants and other plants that are broadleaves that are in that system may be taking up broadleaf herbicides through the root zone. So those are just all situations to avoid. Now, one way to kind of check turf areas is to actually look at them. If you see a lawn or another turf area that's full of white clover or chickweed, you know, that kind of thing, you can probably pretty well assume that broadleaf weed control is not occurring in that situation. Okay, so that's one of the pitfalls to think about. Number of sites, just a brief mention. There is no limit on the number of sites that you can monitor, but just, you know, there's a practical limitation, and that is try to remember that, you know, doing a good job on fewer sites is probably a better idea than stretching yourself too thin and trying to do too many observations on too many sites. Okay, so I'm going to show you 3 example sites here real quickly, and the landscape context, and we're going to think about what some considerations you should be making if you're in a particular landscape context, okay? And first is a rural cemetery bounded on several sides by a cropland, okay? And we'll take a little closer look at it here. You know, the dimension of this, 350 feet by about 350 feet, or the wooded portion of this, about 2.5 acres. So if we were going to monitor the site, this is what it looks like on the ground, okay, the view on the ground. The plan here would probably be to monitor the entire site, but some considerations. This is what we talked about. What should we be thinking about? One, we know there's cropland all around the edges of this, so we should be thinking about, are there edge effects that we need to be taking into account? And secondly, it's a mowed area with turf, and the question is, are there turf treatments of some kind or total vegetation control around trees that we need to be thinking about as well? Okay, so those are the kinds of considerations that we should be thinking about when we're in this kind of environment. Now, here's a very different kind of situation. This is a state conservation area or state recreation, actually a state recreation area. I think its name's been changed. It's Washington County Conservation Area. It's 1,300 acres. So how are we going to approach that? Well, the plan here is to monitor the site by doing it we obviously can't monitor the whole site. So here we would want to try to create a couple of one or two, perhaps subunits to monitor. Again, a basic consideration is edge effects, but when you're in a site this large with this much woods, one of the luxuries you have is you surely ought to be able to just pick a site, a subunit that just avoids edge effects altogether. And that's kind of what we did here. In 2018, we made subunit A, in this case, of 7 acres was monitored, and well away from any adjoining cropland. And a second subunit was also monitored on this at 5 acres, and again, well away from any possible edge effects. And here's the kind of situation that what it looks like on the ground. In the lower right-hand corner, you can see a part of the woodland that was actually monitored in 2018. And finally, here's a third kind of situation we may encounter, say an urban residence. And just to give you some idea of the scale of what we're talking about here, this residence is about 500 feet from adjoining cropland. Look at it a little bit closer. You know, here's the scale. It's about 100 feet by 120 feet. It's about a quarter acre. Okay, and so what's the plan here? The plan is probably to monitor the whole site. It's very small, but something to keep in mind when you're in this environment is, what about turf treatments? Are there some that I need to think about here before I actually do the monitoring? And here's what that situation looks like on the ground. Okay, a few comments about selecting species to document. Okay, there's some general guidelines we can give you about species. These are just very general. Your mileage may vary based on where you are in the state and the particular kind of area that you're looking at. But there's sort of two thoughts that I want to pass along here. And they deal with whether or not symptoms are not present on a site. And that is, for sites where symptoms are observed, document species with symptoms. I hope that makes sense. But there are some subcategories here that we need to think about. Focus on getting data from different plant families or groups. And with regard to groups, we're talking about what Kim talked about earlier, which is the different groups, say in the oak group, red oak group versus white oak group. So focus on getting information from different plant families or groups, focus on important species, and focus on trying to get information from different layers. And we'll talk about layers in a few minutes. Now, for sites where symptoms are not observed, okay, document species, and I hope you will see if you look at this list that the list looks exactly identical to the list up above, okay? We're still focusing on the same categories of species. The only difference is that when you're at a site with symptoms, you don't want to ignore the species that have symptoms. You want to document those. Okay, so this whole idea brings up this idea that maybe not all species are created equal. And so here I want to give you some suggestions and some thoughts about how to focus on species at a particular site, because any site may have dozens to more than 100 species. How do we go about deciding maybe what kind of guidance can we give in terms of trying to focus on specific species at a site? Well, here's one thought. Think about the oaks. The oaks are ecologically important. They're very widespread in the state, so it's a very nice thing. And secondly, they seem to be highly sensitive as a group to displaying the symptoms that we're looking at and looking for. Okay, here's another group of species. These are broadleaf trees, not in the oak group. And I want to draw your attention to the first two in this list. Redbud and box elder. Both of these are widespread. They're quite useful in documenting symptoms from different plant families. The redbud is from the legume family, and box elder is from the maple family. So we not only have the oak family here on the left, but a couple of more families if you're looking for redbud and box elder. They also seem to be species that are almost like canary in the coal mine species that tend to show these symptoms fairly regularly. Okay, also I want to draw your attention to poison ivy. Poison ivy is widespread, and it seems to be fairly, or at least moderately sensitive in demonstrating these symptoms. And also, it's very useful for documenting ground layer symptoms, symptoms that are occurring near the ground. Okay, and then here's a list of some additional species as well. One that's not on here, but it is sort of brought up in my mind is I see some of our fruit orchard trees. They're in the rose family, peach and apple are on here. I want to draw special attention also to Bradford pear. Even though I hate to say that word, it may be a species that also in some of our urban environments may be showing us what's going on there. So just keep that in the back of your mind. Another group I want to draw your attention to is this group of three species, dogwood, sycamore, and catalpa. These are also, especially dogwoods and sycamore, perhaps not catalpa so much, but the first two are widespread. They're useful for documenting the onset of symptoms after full leaf out, later in the growing season. What I mean by that is, in many cases, we're seeing the first symptoms of foliage injury occurring on these species rather late in the season compared to some of the others. So they may be useful for picking up events that are occurring later in the growing season. Okay, well, this brings up the idea of determining a sample schedule. How should we go about sampling? When should we do this? And we just got a quick guidelines on this. It's good to have first observations in early spring after bud break and before full leaf out. Now, this is a fairly short time period. It's probably only 2 to 3 weeks long in whatever location you're in. But to the extent that you can make observations during that time period, it's very desirable. However, I want to point out, and we'll do this a couple of times, it is useful to do this monitoring at any time before leaf fall in many cases. So just because you missed that first window that's pretty desirable, it's perfectly acceptable and desirable to continue on doing observations at any location up until even leaf fall, because these symptoms, once they appear, typically do not disappear. They're usually there for the entire growing season. Now, with regard to repeating observations, a second or even third observation is desirable at a location if an earlier observation was made, especially if it was negative, and so let's think about the value of that. So I'm going to give you an example. We just talked about sycamore as being a species that tends to pick up or tends to be showing us symptoms later in the growing season. By later, I don't mean very late, but I mean not at initial leaf out. So here's a July observation on sycamore. And this is not a terribly uncommon sight in some areas of our state right now. Now, it's a July observation, so a question might be, if we're doing this, we know these plants probably leafed out in April, perhaps very part of early May, depending upon where we are. When did these symptoms occur? Well, we may not be able to pinpoint that exactly, but if we go back and look, if we had an observation on that sycamore, let's say in May, and the leaves look like this, and this seems to be a fairly common occurrence, that the initial leaf out in sycamore looks pretty good, and then later these symptoms develop. That helps us determine a little bit about when perhaps these symptoms actually developed on any species. I'm just using sycamore here as an example, but any species that's healthy early in the season and then shows symptoms later, we have information about when those symptoms occur. Only if we've done the early observation and then have done follow-up observations for those sites. Okay. However, I said I would, when I emphasize this, we can still often get a lot of information from a single observation that's even done later in the season. And here's an example of post oak that was monitored for the first time in late July. And we have curling and cupping indicative symptoms. And if we look at a leaf on the right here in the inset, you can see that this leaf is stunted and has other developmental problems. This tells us, even though we're making this observation in July, that if all the leaves look similar, which they do here, that these symptoms probably developed during leaf out early in the growing season. So we can learn a lot even from observations that are done later in the season. Okay. Okay, so we've looked at selecting sample sites and determining the sample schedule. And we've looked at most of what making and recording observations is about. We have to go back to that for just a moment and look at one other item on the form. We've looked at the observer and location information and the symptoms. We haven't looked at this section on the site ecology. There are just three rather simple questions asked down there that require some data input. The first of these has to do with layers. And we are interested in determining which layers in particular communities are manifesting these symptoms. Those layers are the overstory, understory, and ground layer. So what do we mean by that? These are pretty typical and simple concepts. There's a ground layer, there's an understory, and an overstory. And we're arbitrarily dividing these at 10 feet and 30 feet. This is just an estimate of where these layers are. We suggest that you use about 10 feet and about 30 feet for making this differentiation. So if we look at a typical forest situation, and draw some arbitrary lines through here, basically we've got an overstory layer in a normal forest situation, we've got an understory layer, and we've got a ground layer. So all three of those would be present. Now here's a little different kind of situation. This is almost like a shrub savanna, and virtually all of the vegetation here is in that 0 to 10 foot zone. And so in this kind of situation, we're looking at a community type that simply has a ground layer. Okay, so if we were looking at our form and looking at our instructions, it said strike through if layer is absent. And so this is just a reminder to us of what layers were and were not present. So in that last example where we were looking at perhaps that shrub savanna, we do not have an overstory, we do not have an understory, and so we strike through those. Now, the other part of this tells us check for affected layers. And what we mean by affected layers are layers that have plants with indicative symptoms. So if we have an affected layer that's showing indicative symptoms, we would check it. If there are no indicative symptoms in that layer, we would leave it blank. Okay. Now, the next item is the geographic extent of the observed injury. This just is asking you to characterize the size and configuration of the area that you're monitoring. It's divided into three types of sample or monitoring sites. Large, which is greater than 1 acre, small, which is less than 1 acre, or linear, which is like a fence row or a edge kind of habitat, but one that does not have a root zone uptake problem, however. So let's take a look at what we mean by this in a little more detail. Here's a 40-acre land and water reserve that was monitored in 2017. It's called Sipple Slough Land and Water Reserve. The monitoring that occurred sort of looked like this. This was 2 people walking parallel up and down through a portion of this site. The area that was monitored was actually 8 acres, and I can tell you that all 8 acres showed symptoms, indicative symptoms, in the trees in this location. So if we go back and look at our form, how would we fill that out? Well, this is a large site, okay? It's 40 acres, so it's greater than 1 acre. Type, we can just describe it very simply as upland woods. The number of acres sampled was 8, and the number of acres that showed indicative symptoms, that is the number of affected acres, was also 8. Okay, so that's how that would work. Now, we would ignore the other parts in terms of small or linear, because this is a large site. Let's look at a different site here now. Let's go back to that urban residence and small, about a quarter acre, so it's less than 1 acre. Well, the information we're asking for here is a little bit different. We're asking for the number of trees that are affected. So in this particular yard situation or urban residential situation, there I can tell you there were 15 trees present, 8 of which showed indicative symptoms. And so if we go back to our farm, it's less than 1 acre site, so it's a small site. The type is an urban yard, and the number of trees affected is 8. Pretty simple. Okay, and then the kind of information that we would be asking for linear habitats would be pretty much the same. Now you may say, well, edge of woods and fence row, you just told us not to sample in areas like that, and that's true if those sites are potentially affected by these root uptake zones. However, you might have a fence row in a park, or you might have a fence row in a pasture land, for example, in which case you might not have that worry. So we do have linear habitats that could be sampled. So in linear, we're asking for the type, and in this case, you just characterize not the size of the area, not the number of trees affected, like for large and small, but basically just the length of the area that you're observing or monitoring, and you indicate the unit that you're using in feet or miles. Okay, finally, we have one additional question at the bottom of the form. It is optional, but I encourage you to think about it in most cases, and that is, it's called the injury pattern and land use information. And we have some description in the volunteer guidelines about how to go about doing this. But basically, you record this information in a notes area on the second page of the form. So what do we mean by this injury pattern and potential land use information? Well, let's go back to this Sipple Slough Land and Water Reserve and look at what happened in 2018, a year later. This area was also monitored, and I can show you the approximate path the 2 observers walked in doing this monitoring on this 40 acres. I can tell you that the observers were not inebriated. They were actually trying to walk in those kind of squiggly lines like there to give the most contact with the habitat in the community. Okay, so all 40 acres were monitored. What we found was in 2018, and I helped with this monitoring, relatively uniform light damage on the west side of this reserve, and relatively uniform moderate damage on the east side of the reserve. And so what we have here is a gradient of increasing injury, in this case, from west to east. Okay, and so that's what we observed. Now, it's optional to record this, but probably useful. So if we go to that second page, you'll see a notes area that says optional injury pattern and land use information. And how we might describe that based on the observation that I just showed you, or the monitoring example that I just showed you, is that there was a modest but steady increase in damage from the west side to the east side of the reserve. And that would characterize the injury pattern in this case. Okay, as a final exercise, I'd like to take you on a little digital field trip, if you will, to a typical forest site. And let's take a look at what a monitoring effort might look like on the ground, the kind of data that we would collect and the results that we might expect to see. And we'll call this, this is going to be to a hypothetical bottomland forest, and we're going to give it the name Oak Hollow. Now, this place doesn't really exist, but I really believe this example is not uncommon for what you might expect to see on a monitoring effort. So, just to keep in mind, some of the guidance that we have, this site will have symptoms, and so if we look back at our guidance, we're going to be looking to really focus on trying to get data from different plant families or groups. We're going to be thinking about trying to zero in on important species, and we're going to be trying to think about trying to get data from different layers as well. Okay, that's some of our guidance here. So what do we got? So this particular site has its dominant tree is swamp white oak, and a subdominant tree in this environment is pin oak. So let's look at our swamp white oak first. And let's say we observe about 15 trees in our 30 minutes of walking around here. We look at a lot of different trees, and 15 of those roughly are swamp white oaks. And we notice that about a third of those show level 1 or 2 symptoms. And that's what I've kind of illustrated in this slide right here on the swamp white oak leaves. Those are about relatively, that's probably a level 2 symptom. And about 2/3 of the swamp white oak that we see during our walk around show no injury at all. So the injury level on those is 0. This is not particularly uncommon, this kind of variation, especially at lower levels of foliage injury. Many of the plants may not show any injury at all. Okay, so what have we learned here? Well, we've got a member of the white oak group. We've got a very important species in the ecosystem. We've got a member of the beech family, and we've got a species from the overstory layer with this swamp white oak. Okay, so we keep walking and we notice that pin oak is pretty common in this bottomland forest too. And when we look at walk around, we see about 10 of these in our half-hour visit perhaps. About half of them show level 1 to 3 injury symptoms. And on the screen, I'd say that's about a 2 or a 3, probably a 3-level injury on pin oak. And about half of them are 0 again. About half of them are showing no symptoms at all. And one of the things we want to point out here is that you should expect a lot of variability in any site you go to. Every tree, every member of the swamp white oak trees in this forest, or every member of the pin oak in this forest are different, and they're different genetically. And so their particular reactions to environmental stressors are going to be different. So it's not unusual to see this kind of level of variation among their species. So here's what we got for pin oak. What have we learned? Well, when we added pin oak to our sample, we now have a member of the red oak group. We have another important species in the ecosystem, an oak. We still are in the beech family with this oak, and we've added a second species in the overstory layer. So we've got some more information here. Okay, as we walk around, we locate some redbud in this bottomland forest. And let's say we observe 3 trees, and all show about level 4 symptoms, which is kind of illustrated in the slide in front of you. So what have we learned here? Well, we've added an understory species for certain with redbud, and we've added information from another plant family, the legume family. Okay, and we continue our survey. We're walking around, and we find, fortunately, some box elder, which is a very useful species in several ways. And we observe 5 trees in this area. All show level 3 or 4 symptoms in that neighborhood. Okay, well, what have we got now? We've added another plant family to our list of families that we're looking at, the maple family, and we've added a second understory species, because most of the box elder are probably in this 10 to 30 foot range that we're coming across, although some of them might be in the ground layer as well. And finally, we see poison ivy. In fact, poison ivy is spread all across this habitat. So we walk around, we're not counting individual plants, but we know we observe at least 100 plants or more. So we might write down, in terms of the number of plants that we observed in our form, 100 plus, and when we fill in the data on our sheet, electronic, which Ken will be talking about later, we probably put in 100 or 200, something like that. All average a level of 2 symptoms. As we walk around, we're just estimating that. But we did keep track, and we noticed that some of the poison ivy doesn't show any symptomology, and about the worst that we saw was a level 3 symptoms, level of injury. Okay, so what have we done here? We've added a species that's definitely from the ground layer, and we've also added another species from another plant family, the cashew family in this case. Okay, so thinking back about our guidance for a site in terms of what's a good species to focus on in a community that is showing symptoms, if we think about plants from different plant families or groups, important species, and from different layers, what has our data from Oak Hollow shown us and given us, basically? Well, for the Oak Hollow data, we have data from 4 different plant families. We have oaks from 2 separate groups of oaks. We have important species monitored, in this case, especially oaks. And finally, we have data for species in all 3 forest layers. And that's a pretty good characterization. And we've done that by monitoring just 5 species. So just to give you an idea of, again, what a typical monitoring approach might look like, in a hypothetical but close to real life kind of situation. Well, that's all I have to say. You may say thank goodness, but thank you for listening, and really appreciate your attention to this matter. I'll now turn this the mic over to Kim.
Thanks, Marty. So we have one more thing that we're going to go through before we move on, and that is talking about how to name photographs for the monitoring. We're going to name these two photographs. On the left is a rough leaf dogwood, and on the right is a red bud. And we do have a rule that we're asking you to use, and that is the site name _ species name _ date _ photo number. So, for example, we're going to name these two photographs. The site name for this location was River Road Field _ R Dogwood. Any abbreviation would work. What she used here is fine. And the date, 6/21/18, and then it's photo number 1. Now she is uploading 2 photographs of that rough dogwood, and so the second photograph is River Road Field, R Dogwood, 6/21/18, and then photograph 2. And for her third photograph is of the red bud, and that would be named River Road Field because it's at the same site, red bud _ 6/21/18, and photograph 1. So pretty straightforward and pretty simple. Now we're going to go on to the last section of the training. And for those of you that are not familiar with this animal, this is the Polyphemus moth, and on the left is the very large caterpillar, and on the right is the adult moth. And they're an important moth species to Illinois' forest and woodlands, and their host trees include maples, oaks, and ashes. So now we're going to go ahead and go into the online reporting form. You do need to have a Google account in order to use the online form. So either a Gmail account or just a regular Google account. And that's because we're asking you to upload photographs into the form. If you do not have a Google account, feel free to go ahead and just email your monitoring form and photographs to us at monitoring@prairierivers.org. Now we're going to go ahead and click on the link and see what it looks like. Okay, so here we are at the tree injury report form, and we're going to enter in a fictitious monitoring report for a Jane Smith. So we're entering in the personal information, and you can note here that the fields with the red asterisk you have to fill out in order to move on to the next page in the form. That is required information. Enter in the email and click Next. The site name is River Road Field. There is no subunit listed. The site is located in Jackson County. I have a pull-down menu here for the date. I'm just going to go ahead and type it in, 06/21/2018. No witness was listed. This initial visit was not planned. It is the first visit. And we're going to enter in GPS coordinates and decimal format. And the GPS point was taken in the southwest corner of the monitoring area. Click Next. We're going to enter in just 2 species from this form today. You can enter up to 10 without having to move on to a new form. Click Next. And we have a pull-down menu here for common names. We're going to enter in that rough leaf dogwood that we just named. There is a spot for common name if you cannot find the species you're looking for on the pull-down menu. You do not have to enter in the species name, but we welcome it if you know it. She observed 7 rough leaf dogwoods And the average injury of the foliage was 75 to 100%. Injury level was at a 7, with the lowest injury level being a 7 and the highest injury level also being a 7. So pretty consistent. Leaves were cupped and curled, and that is the only indicative symptom she listed. No additional symptoms were listed. And we're going to upload our file, our photo. And as you can see, this moves along pretty quickly once you have all of your information in front of you. Scroll down to the bottom, click Next, and we can move on to our second species. And that was the red bud. Again, she observed 7. 75 to 100% of the foliage was affected. Average injury level was a 7. The range was a 6 to an 8. And again, the indicative symptoms listed were leaves, curled, and cupped. No additional symptoms were recorded. I'm going to upload that photo. And scroll down to the bottom and click Next. And this will take us to our final page, the notes section. And she does have something listed here in the optional injury pattern and land use information. And this says it's an edge of a grazed pasture. So we're going to write that in. And scroll down to the layers section. Overstory was present and affected, and as you can see here down at the bottom, this question requires 1 response per row. So the understory was also present and affected, so we're going to click that. And then since this was a grazed pasture, the ground layer was absent. And the shape of our monitoring site was linear, and we're just going to make a note of that, edge of pasture. And then we're going to estimate the length here at 1/4 mile. And we're done. We're going to click Submit. Now, at the end of this form, when you hit Submit, you'll get this page. And if you have other monitoring forms to enter in, you can click here and submit another response. But for now, we're at the end of this monitoring program, and I just want to take a moment and thank everyone for participating. We would like to thank you for taking the time to learn about the program, and we hope that you're able to help us gain information and knowledge about this important topic. And if you have questions, please feel free to email us at monitoring@prairieriver's.org.
Thank you, everybody.